Welcome or welcome back at C squared. In this lesson we're going to talk about congruent triangles, and we're going to talk about some ways to prove congruency. And the first way is the side congruent triangle, which the short way is SSS. If three sides of one triangle are congruent to three sides of the second triangle, the triangles are congruent. What do I mean? Look at here. If AB congruent with DE, BC congruent with EF, you see the same mark, and AC congruent with DF. If these three corresponding sides are congruent, then the triangles are congruent. That's what this theorem says. So let's take a look to this example which says what information is needed to prove that the triangle below are congruent using this SSS congruence postulate. So let's take a look. What do you notice here? We have these two sides congruent, MN congruent to RT. We can see that in the picture. Then we have two more sides, NQ and RS. And for using that side, we did a third one, which are these two. MQ has to be congruent with this one, TS. Okay, so this is the information needed. Now let's go to the last part and write a congruence statement. On this one, you really have to be careful how you match the letters. So, for example, you can start anyway the first triangle. Let's say you say triangle MNQ, right? Okay. First triangle you start wherever you want. What would be the second triangle? In this one you have to have the corresponding sides. Okay, so you take a look at M. M is at this intersection of the side that is marked with 1 and the one marked with 3 marks. So that will be in this case letter T. Then we look to N. It's the intersection of the side that is marked with 1 marked and 2 marked. So which one is going to be this? Is going to be R. And the last one obviously is going to be S. So be sure you match the corresponding letters. And then you can also check by looking to your original statements, the one you see here, if they are correct. Okay, a very, very similar problem. The only difference here we have this triangle have a common point, right? They have that Y that is part of both triangles, the vertex of both triangles. So the same question, what information is needed to prove that the triangles below are congruent using SSS congruence postulate? Okay, so we're looking again, we notice AB congruent with HL. So we have the first S in this SSS postulate. Then we have the second S, BY congruent with YL. And we need the third S, right? YL is this one. Which are these two guys? 1, 2, 3, AY congruent with YH. And you notice, by the way, I forgot to mention that be consistent and use start with the same triangle always. So this, okay. And now let's see how we write that congruent statements. Let's say you say triangle what? BYA. It's congruent with what? And now let's try. Like looking, we start with this B. Okay, the intersection of 1 and 2 marks sides, so that will be L. Then we have Y, which is the common vertex, and you notice either way in both triangles, Y is the intersection of the sides marked with 2 and 3 marks. Okay, so Y, and obviously the last one will be H, LYH. Very important to write correct statement. And this is the information needed, remember that. Okay, in some cases I said triangles share more than a vertex. In this case they share a common side. Okay, in this case we see that FG is the common side, which I can mark it like this. It belongs to both triangles. So my first statement here will be EF. Segment EF, let's be correct, congruent with segment GP. We notice they are marked the same. And then we have that common side. Look at here how I'm writing that. FG congruent with FG itself is that reflexive property we talked a while ago. And now what is the information we need to prove by SSS? We need these two sides, EG and FP or PF, doesn't really matter. They need to be congruent. This is the information needed to prove these two triangles are congruent using the SSS postulate. Now let's write the congruent statement. Like I said, I'm going to start anyway. You can start anyway. EGF. EGF. Congruent to what? What is the corresponding for E? It's going to be P. What is the corresponding for G? That will be F. Be careful here. And what will be the EGF? That will be the G here. Okay. So that is about this problem. And you notice now we finish everything. Okay. You can use, I said here, SSS postulate on the coordinate plane. We have these triangles and we get the vertices. So you may want to grab some graph paper and plot these vertices. It helps. And then we have the triangle MNP. We have also the vertices right here. So plot these points. I think it's good to do it. Draw this triangle on coordinate plane and prove that these two triangles are congruent by SSS postulate. I did it right here. You notice? Okay, now let's take a look. They look congruent, by the way, right? Look here what you want to do. First, let's start with this one. 1, 2, 3, 4. MP is 4 units and AC is 1, 2, 3, 4. Okay, so we know MP it's congruent with AC because both of them measure 4 units. Okay, but now let's take a look to another set. I'm gonna take a look to PN and BC. You see, I marked them the same. They are congruent. But how do I prove that? Look at here. I have this triangle here, so I can use Pythagorean theorem. This is 3. This is 1. So I'm gonna have A squared plus B squared equals C squared. And that will be 3 squared plus 1 squared equals C squared. So C squared is 9 plus 1, it's 10. And C, which is going to be nothing else than NP, will be square root of 10. We can leave it like that. In fact, we cannot simplify. If you do the same math here, look at here. This is 3, this is 1, 3 and 1. If you do the same math, how much do you think BC will be? BC will be also square root of 10. So now I can write this statement here. NP congruent with BC. They both have the same measure of square root of 10. And we have one more side to check it. So by the way, we check these two. They both 4. We need to check the last one. This one. And this one. You see, I marked them the same, but I really need to see if they are the same, right? Maybe they are not. But let's take a look. In this case, I'm going to use this triangle. And you notice this is 3 and this is 1, 2, 3, 4, 5. 3 and 5. Again, I'm going to use Pythagorean theorem. A squared plus B squared equals C squared. So I'm going to have 3 squared plus 5 squared equals c squared. So I'm gonna have 9 plus 25 equals c squared, and that means c squared will be 34. But see, be careful now, in this case is mn. So mn is square root of 34. We cannot simplify, leave it like that, and we don't need it also. But now let's take a look at the other triangle. Okay, again, I'm going to try to find the length of segment AB, right? So I can use this triangle, and you notice this is 3, this is 5. So this AB will be also the same thing, square root of 34. It cannot be different. So yes, ladies and gentlemen, we can say here the segment MN is congruent with segment AB. Why? Because they have the same measure of square root of 34. So now we can say what? Triangle ABC is congruent with triangle MNP by the SSS postulate. So it looks like a proof here, this one, and yeah, I'm trying to justify using a type of proof. Okay, so this is this example. Let's move now to another way to prove congruency, and that is what we call side angle side SAS, congruence. This is a theorem, important. The previous one was a postulate. This is a theorem, which means eventually you can do some geometry and you can prove it. Okay, and let's see what this says. If two sides, and this is a keyword, included angle of one triangle are congruent with two sides and the included angle of the second triangle, then the two triangles are congruent. Let's see a picture here. I think it's going to help you to understand. Look at here. These are the congruent sides, AB and DE, you see it here. BC and EF, you see the second one. Look at here, these two angles are the angle included between these two sides, If we have this pattern, if we have these criteria, then the two triangles are congruent by SAS, congruence theorem. So let's see this example. If you notice, it's very similar with something we did before. We notice we have MN congruent to RT, we notice also NQ congruent to RS, the same marking. Okay, so we need one more thing for that side angle side. It's the angle included. This angle N congruent to this angle R. So this is the information needed to prove these two triangles are congruent. Let me write in the statement triangle, and again you can start anyway. Let's say you start NMQ. So the first triangle you can start anyway. Congruent to what triangle? Okay, so now the corresponding will be R. You see they are marked the same. What will be the corresponding for M? For M will be T. And what will be the corresponding for Q? That will be S. Okay. The second example, very similar to something we did before. Now these two triangles have a common vertex. And in this case, we're looking at the same thing. We need to find what other information is needed to prove these two triangles are congruent. So by SAS congruence postulate. So you notice very similar. AB congruent with HL. You notice BY or YB, either way is good, congruent with YL. You can see that in the picture. So we need an angle. What angle should be in order to use that SAS? The angle included, angle B and angle L. That's the thing we need. Angle B needs to be congruent with angle L. we can write this just using one letter, right? And then these two triangles are congruent. So let's say we say triangle YAB. Okay, now what is the corresponding for Y? It's Y again. What is the corresponding for A? It's H. And obviously the last one will be L. Okay, very, very important to write the correct statement. And this will be by side angle side. You notice we have that pattern criteria listed on the left. And again, we can have this case where they share a common side. This side, if you remember, right? They share a common side. Okay, so we have EF congruent to GP. Then we have that common side. If you remember, that is what we call, if we write a proof, reflexive property. Okay, and then we need an angle to use SAS congruence postulate. Which one? This one. I'm gonna have to name it using three letters. EFG needs to be congruent to what? This angle, because these two angles are included, and that one will be PGF. Okay, so this is the information needed to prove using side angle side congruence theorem. And now let's write the two triangle EGF. I'm gonna start with that. And now what is the corresponding letter for E? That would be P. What will be the corresponding letter for G? That would be F. And what will be the corresponding letter for F in the first triangle? That would be G in the second triangle. Okay, and that's it for this problem. My last problem, we're gonna take a look at two proofs, and we're gonna start with this one. What is given is that AB congruent to AC, and you notice I mark them on the picture. Sometimes that is very helpful. So we finish with this statement. The second statement says D is a midpoint of BC. What does it mean? That means the BD congruent with DC. Okay, and we need to prove that the two triangles are congruent. Look at here, these two triangles share a common side, this one. So that is going to be a side. So this is a way to have a, rough draft to write a two-column proof or a flowchart. I'm going to do a two-column proof here. So we're going to have here statements, and reasons, and we're going to start with what is given. And I'm going to start with the first one, AB congruent to AC, and that is given. Okay, now I'm going to start with the second thing, D is midpoint. Of segment BC, and that's also given. And now I'm going to write this statement, BD congruent with DC, because this is a midpoint. BD congruent with DC, and the reason is definition of midpoint. Midpoint of a segment, in fact. Okay, so we have the two sides as, you see this as, you don't have to write like this, but I just want to be sure, as, and then we have a third side, the AD, it's a common side in both triangles, AD congruent to itself, AD, and if you remember, this one is called reflexive property. Reflexive property of congruency. I'm just going to stop here. And now we can say triangle ABD congruent with triangle ACD by side. You notice we have three sides here. By side. And remember, this one is a postulate, is not a theorem, in case you need. And this is the two-column proof. The flowchart looks very, very similar. I'm going to show in fact the flowchart for the next problem. Just be sure you see both ways. Okay, so in this one we have given AB congruent to AC, very similar, right? These two are congruent, but now it says DA bisect angle BAC. That means these two angles are congruent, because that's the meaning of bisecting an angle bisector, how we call it. And now we need to prove the two triangles are congruent. Again, if you notice, this side is the common side. So I'm looking here, and my first thought is that I'm going to use side congruence theorem. So let's see. I'm going to start, and I said I'm going to do a flowchart here. What is given? AB congruent with AC, and the flowchart can look in different way than mine here. I'm gonna do it this way. And what's the reason here? Given. So you see how the flowchart looks, right? Write the statement and the reason one under the other one. So this is given. Now I'm gonna go to the second thing which is given, which is the fact that DA bisects angle BAC. Okay, again, I'm gonna box this guy, and I'm gonna write the reason. Which is the reason here? Given, right? This is given to us. But from this guy, I can write the next statement, which is these two angles are congruent, this angle and this angle. And we need to use three letters. So I'm gonna say BAD, angle BAD, congruent with angle CAD. Okay. And why do we have this statement? Because this is definition of angle bisector. Okay, so we have the side here, and you don't really want to write this like that unless it helps you. Have the angle, we need the third side, the third corresponding congruent part, which is that AD congruent of itself. AD congruent of AD, and if you remember the name of that property, I think you should. It's important, it's easy. What is the name? Reflexive property, right? Now look at here, from these three statements, this one, and the first one, I can write the last one, which is triangle ABD congruent with triangle ACD. And why? Remember, we have here side, angle, side. I forgot to put that here, but in case you need it, side, angle, side. Be careful, this is a theorem, is not a postulate. If you enjoyed this lesson, don't forget to click the like button and come back on C Squared for more help. Thank you.